All right. That's the wrong thing. There. Everything's broken. Right. The settings. Uh, okay. Screen capture's up. Webcam is up. No, it's not. For some reason. There we go. Header. Hell's a header? No. Don't need the header. Oh my god. Okay. This is set up. This is set up. Everything is set up. Everything should be fine. Alert box. Chat box. Chat box can fit here, I guess. Okay, we're back. We're back to our pre-messed up layout. I do apologize for having to do this on stream, but it is what it is. You get bad days, you get good days. Just roll with it. Okay. But we can finally get back to our scheduled programming. All right, so in the last few exercises we used columns as an existing database table. Use columns in an existing database table with data already inside to create new tables, then dropped out the redundant information from our original table. While this kind of table and schema modification can and does happen, it is much easier and often preferable to implement a schema design before the data has been inserted into the table. This is because existing data might already violate constraints that we would like to impose under new structure. Moving and dropping columns is also not quite enough to turn this single college table from the exercise 1 into 4 table versions we likely would have designed if starting with no existing tables or data. For example, the two figures below show the original schema compared to blah 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 blah. Yes, we read all of this, I think. Now we're going to create tables. All right, so create the advisors table from the schema diagram with columns in the same order. Make sure to include any relevant primary and foreign key constraints and add a unique constraint to the email column. Okay. So create table advisors. ID int primary key unique. This shouldn't be an int. This should be like serial. But I don't think they have that, so let's keep it int. Email. Make sure to include any relevant primary and foreign key constraints. What do you mean? We're just creating one table. What constraints? And name. And department. All right. That seems about right. Yeah. Add a second create table. Add a second create table statement below the first to create students table with columns in the same order. Make sure to include any relevant primary foreign key constraints. So we have primary thingy going to advisor ID. Okay. That's 100 year. Students year. Okay. Makes no sense, but I'll roll with it. Email. I think that should be okay. No, it's not. Integer. Oh, email is unique. Okay. I don't need the unique on the primary key, I guess. Third, create table majors. And majors has a connection with students majors. Oh, it's a joint table. Okay. ID. Major. 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 General. Private. Creds. Credits. Rect. 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 Ribbit. Ribbit. Integer. Yeah, looks about right. And then we create a join table. Create table students majors. And we need student ID, which will be an integer. And we also make it reference to references students ID and major ID. And we need a And we need a joint primary key. Student ID and major ID. I think that's how you do it. Can't remember exactly. Columns make sure to include any blah, 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 blah. No. It was wait, just these two? Don't need this? Okay. If you say so. I don't think we should. Spooky, scary, spooky, scary, spooky, scary, spooky, scary. Scary, spooky, scary, spooky, scary, spooky, 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 spooky. Throughout this lesson, we've seen how poor database structure can impact our ability to store, modify, and ask questions in our data. In the last few exercises, we saw some possible ways to modify our database to address these common problems. While it often makes sense to break up large tables in this way, there are no universal rules about the best way to design a database schema. Sometimes the most important design consideration is how a database will be used in the future. For example, if a particular column of data is never going to be modified, then data duplication in that column is less problematic. In order to see how the changes we implement in this lesson have impacted our ability to work with, with our database, let's return to some of the issues we've encountered in previous exercises. Let's see how the normalized four-table structure addresses some of those problems. So the student's major and majors tables have been created for you. The student's majors table contains columns, student ID, created for you. I've created them just now in the previous lesson. Don't lie. Student major blah, 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 major blah, blah, blah. Fill in the blanks in the provided query to produce a list of majors and the number of students who have declared them. Sorted by popularity. Mondays, man. What is up with this day that messes up so many people? Kind of getting warm. Let me open a window. Actually, should I open a window? I should open one in the kitchen. Give me a sec. Okay. This should help. Maybe some fresh air too to wake me the fudge up. Bum, 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 bum. Bum. Okay. Copy that, paste it here. Instead of this, I think we do majors. Major. And order by Didn't expect you still working on learning SQL. Oh yeah. Hey, happy. Yeah, there's a lot to learn apparently. Indexes, triggers, stored procedures, functions, permissions. I'm basically covering everything. Because like typically, as far as I know, it's like split into three parts, right? It's like modification, then permission part, and then creation. So like you could, at the end of the day, you're actually better than I am. I would argue with that. I tried today, actually, the company that's trying to employ me. It sounds so funny too. Company that's trying to employ me. But yeah, they send me a package with like information to learn and some exercises to do in their own like database playground thing that they have. And I tried creating the tables. It's fine. Creating the tables was fine, but I also wanted to do some, relationships, foreign keys, blah blah blah, and I just couldn't figure out how to do it. So I was like, I sent an email to my mentor and I was like, "Yo, do you have any more documentation on this thing? Cuz I cannot make ends meet here." And he basically replied, "Don't worry about it." He's like, "Try your best. You can make mistakes, who cares? Drop the tables, try again afterwards." And do your best and just move on. So, yeah. Though, like, the first half of the stream today was an entire, like, it was a mess. Should have seen it. I tried to do the exercises, which I cannot technically show on stream because I've signed an NDA and it's like their intellectual property and whatnot. So, I was basically just like having my dog cam on and having the YouTube video music play thingy, just showing whatever the video was showing. I've been streaming for 5 hours. Yeah, dude, I stream 8 hours every day, minimum. So, it is what it is. Yeah, but the first half of the stream was like it was a cluster F. I'll have to figure a way out how to do all the material somewhere off stream. I'll have to find some time. I will either shorten the streaming times a little bit and maybe then on top of that do the exercises off stream or just do them on the weekends. I don't know yet. If you don't get the job for knowledge, you should get it for motivation. Well, I mean, I don't know. Like it's interesting and I think this is one of the reasons why I think programming is for me is because with programming as opposed to with other things, I don't get as frustrated when things don't work out. I just bang my head at them until I get it. So, like I do get like of course it's a little frustrating when you don't get something, but you can always look it up, learn it as opposed to other things. So, I remember trying to draw. I was trying to do drawings and I was so bad and I'd get so frustrated because it's not very clear how to get better. It's not like you have an idea. Okay, so I want to draw this character, right? And you can't draw for crap. And what where do you go from there? Just practice the same character for hours upon hours upon hours? Like, sure, that's you could do it that way, but also it's much less graspable, I guess, the way I would say it. All right, I've started babbling. So happy. How's your weekend been? What have you been up to? How's your Monday? Cause mine's garbage. Order by major, I guess. No. Did you produce a list of majors and the number of students who have declared them, sorted by popularity? No. Order by count. There we go. An advisor table has been created for you with advisor email, name, department. The email column is constrained as unique because we now expect no duplication in this column. Sure. Below your query from step 1, copy, paste, and fill in the provided code to update the advisors table, such as blah, 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 blah. Summer. Okay, it's this easy stuff. Is it advisors? Yeah, advisors. Set email. Copy, paste this. Oh, not this whole thing. Where name equals summer. Duplicate key value violates unique constraint. Oh, so it's just a confirmation that it works. Okay. Hey, Codecademy, your website's broken. I can't close this message. But we should be able to finish databases today, I think. We're finishing with normalization, then we have one more project. We also have to finish up the intermediate bookstore indexes project, and that should be it with databases. I think. I hope. God, I hope. I'm kind of getting database overload here. In the last exercise, we saw how the normalized four-table database schema solved some important problems. But it's worth noting that normalization does not exclusively make queries and modification easier. When we split a large database table into multiple smaller tables, some queries may actually become more complex. This generally happens when a particular question about the data now requires two or more tables to be joined back together. Usually, this added complexity is worth it in order to maintain simple database structure and data integrity via constraints, but it's useful to understand the slight trade-off. Yeah. Okay. So they've created three tables. Suppose that you're asked to email students a reminder about a number of credits required for their majors. To answer this question, you need to join students table, blah, 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 tables back together. Okay, let's see if we can do this. One tip that I saw, I started watching this series about TSQL, Transact SQL. Oh my god, I got the hiccups. Anyway, they stated that an easier way to write queries is start from the from statement, because that's how queries get interpreted by the database manager itself. So it first looks at where we're trying to get the data from. It looks at any filters that we're applying. It groups it up a little bit, and then it looks what do we need from that information. So let's try to apply that. So from students. Oh, it's like a simplified joint statement thing. Students, majors, and majors. Where students be equals majors dot student ID and students majors dot major ID equals majors ID. That should be it. Select, and we're selecting student ID and what else? Credits required. Yeah. Credits rect. Is that correct? That's correct. Holy crap. That's a lot of students. Now, edit your query from step 1 to replace the credits required column with a column named total credits that contains the total number of credits required by each student. Oh, okay. So we do sum student ID. We also need to group it probably. Group it by... No, wait. Now name total credits as total credits. Credits, not TIDS. But we're also getting column student blah 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 must appear in the group class, use the aggregate function. No, it doesn't. Okay, we can do a group. Group. Oh wait, no. It must appear. Oh. Group by sum? No, that doesn't work either. Students majors dot student ID must appear in the group by clause or be used in an aggregate function. It is being used in an aggregate function. Group by student ID. The hell? Group by student ID. Oh, it's the frickin' semicolon. Okay, we got the thing. But we're also min? Email? The hell? Edit your query from to replace the student column with a column named total credits. Done. That contains the total number of credits required by each student. Semicolon? No. What's your problem? Credits rect. Oh, I'm summing up the student's ID, not credits. There we go. I was starting to think that seemed like a bit too much, too much credits required. Finally, edit your query from steps 1 and 2 to also return the email column from the students table as a third column named student email. Note that because you're grouping by student ID, you will need to aggregate any other column you query. However, because the email column is unique for every student ID, it doesn't matter how you aggregate. We can, for example, use min to get the first email associated with each student ID, and this would yield the same result as max email. Oh, okay. So there's the third column. So some email, or no, not some. Let's do min. Email as student email. Okay, we got the thing. We did the thing. Look, Mom, we did the thing. We did the thing. You know, the thing of the thing. With the thing. By the thing. Quiz! Consider the following two versions of bookstore database. Note that some authors in your database have written multiple books. In which version would it be possible to constrain the email author email column to be unique? So definitely B, because if they have multiple books, we can only type in here. So version B only. Suppose that you have an orders table with the columns named order ID, order timestamp, order cost, customer ID, customer address, and customer phone. Jesus Christ. If at least one customer has made multiple orders, which columns, if any, must contain duplicate data? ID, address, phone. ID, address, phone. Yep. And start a war. True or false? Normalizing a database always makes queries more simple and efficient. Absolutely false. Liar! Liar! Which of the following is a reason that you might want to create normalized database tables before adding data into your database? Instead of normalizing your database by splitting up when database table is split into two smaller tables, it becomes impossible to join those two tables back together. Like, no. I want to create normalized database before adding data. Insert data may already violate constraints that you would have. Yes. Suppose that you run a music store and have the following database table. The column data songs by the coders is going on sale, and you want to change the album price accordingly. What is the problem with the following PostgreSQL code? Update songs. Okay, set album price equals 899, where album name equals data songs. Well, we have multiple. It's not normalized. We have multiple album names called data songs. There are two different albums named data songs. There's actually three. The first key should be alter instead of update. No, the statement will only update the first instance. No. There are two different albums named data songs. And you have not uniquely identified the one by the coders. There's three. I feel like this is the correct answer, but like the first keyword should be alter. No. Statement will only update the first instance of the album data songs. No, it will update all of them. It is impossible to... What the fudge? There are two different albums named data songs. Am I having a stroke? There's three. One, two, three. Codecademy, what crack are you smoking? Album name, where album name equals data songs. There's three. There's three. Okay, I'm losing my mind. Let's move on. Suppose that you have an orders table with columns named order ID. Oh my god, this again. Due to the repeating item columns, which of the following queries would require union or a join? Huh, good question. A query returning the number of orders containing each item. A query returning the number of orders containing each item. A query returning total number of orders made by a particular customer. Query returning the number of orders per unique customer. A query returning the number of orders per day in June. Am I crazy, or we can actually return all of this without doing a join or a union because we only have one table? What the fuck? A query returning the number of orders containing each item. Why? I thought like in June, right? So that implies that there's another table with dates somewhere. But okay, whatever. Suppose you're a bookstore owner and have a database table containing the following columns. A new author reached out about a book they're writing. They want to do a promotional reading at your store before their first book is published. When you go to add the author's name and email to your database table, which of the following problems will you encounter? You'll need to delete and recreate the table. No, you won't. There may already be an author with the same name in the table, which would prevent you from inserting the new author's information. No, it wouldn't, because the new author's information is not unique. You'll need to create a separate author's table in order to add in. No. You'll need to create a fake book ID in order to enter the author's name and email into your database. Yes. Yeah. So version B only. Hey, Joker. How's it going? How did your stream finish last night? Giggity, giggity. What is that emote called? WitchCon hype. Okay, I would call it giggity. It's good chilling at work. At least someone has a chill Monday. Jesus Christ. What a morning I had. All over the place. For real, yeah. Just a bunch of garbage this morning. Like, okay, so I'm telling this story like the third time today, but Jesus. Anyway, I had the company that I'm applying to, they sent me more material to look through. And among that material was exercises, which I was supposed to do in their own sort of private database management system playground thing that they've set up for recruits. So I was like, okay, let's do it on stream today. because I wanted to get into it. It's like new exercises, very exciting. I wanted to do it, wanted to play around. Problem is, I can't show any of it on stream because I've signed an NDA basically. And so the solution that I had was I've set up the scene in Streamlabs was basically half the screen for Thorcam, half the screen for a YouTube video that I'm currently playing, like just like screen grab the YouTube player for each song, and then half the screen for chat. But it was just terrible because like even I got into the exercise. It was kind of okay, but then I kind of got stuck because their database management software is just odd. It's nothing that I've seen or encountered before. Not that I've encountered a lot of them, but it was very confusing. So essentially, I was just like trying to figure stuff out and not actually doing anything for the entire morning. And that was basically the stream, just me sounding confused while the music was playing and Thor was sleeping in the background. Anyway, so I decided that I'll probably do those exercises and all the other training material off the camera. I just haven't decided when. Either I will cut the streams a bit shorter, like a couple of hours shorter every day until I go through it, so I would have the time to do that because I also need time for myself in the evenings, like make dinner, relax, chill. Cuz I'm going to go nuts if I don't. Or I'll do it on the weekends. So, we'll see. We all come for Thor anyway. Wow. Okay. Yeah, sure. Let me just mute this microphone here quickly. And Thor, the scene is yours. Oh, wait, you're sleeping like you usually do for 14 hours a day or something. Mm. Yeah, I thought so. Ah, crazy morning, crazy Monday. Which of the following is a reason that you might want to create a normalized database tables before adding data into your database? Constraint stuffs. Customer ID. Let's get through this quickly. Is this the same one or is this different? Note that some authors in your database have written multiple books. Which version would it be possible to constraint author email? Be only. Suppose that you have an orders table with columns named order ID, primary key, item stuff. So, containing each item, yes. Database normalization is a process in which database and table structures are created and modified primarily to address inefficiencies and or problems related to which of the following: data storage modification querying, missing or inaccurate data in existing database tables, database security and permissions. Storage modification querying, yeah. And finally, in order to normalize a database that contains the following table, which columns should be moved to a separate table? I would move obviously the song artist and album because it's duplicate data here, and duplicate data here. So album name and album. What? No. Song name and song artist? Why? Never guessed what? I wouldn't change anything. All are relevant. I mean, you could make an argument we're moving album to a different table because basically every song, like imagine you have 20 songs in an album, this is just going to be duplicate data. It's going to be album name, same price, album name, same price, album name, same price. So album name and album price, I get. Song artist, there's also an argument for removing that because it's also duplicate data. But there's only one column, so it's going to be the same thing either way. Okay, so album name and album price. Yeah. The reason why this is because essentially what you're doing is taking this one table, making it shorter, and instead of two columns with duplicate data, you will have one column with duplicate data, which will be just numbers, 1, 2, 3, and so on. Yeah, and then you could join them together when querying. Like they said, it makes querying a bit more annoying, but that's normalization for you. Okay. So we have this project, but before we can tackle this project, we have to go back to the project that broke Codecademy. Okay, it's not broken anymore. Irfan SH98. How's it going? Oh my god, what? What is it? What do you know that we don't? Why are you freaking out, man? How's it going, Irfan? Beer BVC. NP, bro. NP. How you know I have a DB final next week? I know, bro. Everyone has a DB final next week. I had a DB final today. Well, not a final, I guess. Just some exercises. You can brush up your knowledge here. Oh fuck. What were we what in the hell were we doing here? It's been so long since this exercise. You might have noticed that when you go to the top 10 records from a customer's table that they weren't in numerical order by customer ID. Use your new primary key to fix this so the system is ordered in the database's physical. In the database physical by customer ID. To verify this work. Ask question, I'm ready. Okay. What are the cons and pros of database normalization? Don't know if I asked a hard question or not. I can answer it, I guess, a little bit. We just tackled that. Okay, so this. Wait, at the start project, you were asked if you could find what index was missing. Wait, we created the primary key, right? Orders, books, and... No, we didn't. Okay, we need a primary key here. So, uncomment this. This should add the primary key. Yeah, so now we have one on customers as well. However, reduce redundancy, that's all I know. Well, yes, that's the pro. What are the cons? You reduce redundancy, but what happens then? What problems that creates? You can do it. Think about it. Think about it. Top 10 records from customer table. They weren't in numerical order by customer ID. Well, let's take a look if they are actually are or not. Okay, they're not. Wait, has something to do with clustering, I think. Simulate a system that has experience updates, deletes inserts from a live system. Use your new primary key to fix this so the system is ordered in the database physically by customer ID. Wait, primary keys make the query more complicated because you should do a lot of join and stuff? Yes, exactly. Good job. You know your stuff. Okay, what other question can we ask you? Huh. I mean so many, but like I'm trying to ask them some sneaky questions. Let's see. Wait, this like on the tip of my tongue, this like interesting fact that I Okay. Here. If we have a query like this, select all, say from customers, where customer name equals John, for example, and let's order by customer name. And limit to 20. In what order will this query be executed? Okay. Okay. It's I just learned that yesterday. It was news to me. I guess I assume you're like going doing a comp science degree, right? You're going to like a proper university or something to be having exams from where orders select. Yeah, okay. Yeah, okay. Yeah, so that's the main difference, I guess, is that like some knowledge comes later to people who are like self-studying. Uh, I just learned that yesterday. I have a project. Can you check it out? Sure. Great bugs, single great jobs. uh, wait, how do we reorder this stuff again? Hmm. On GitHub, not the hero we deserve, but the one we need. Ain't that the truth? Sure, let's take a look. That's a nickname and a half. Erfan Shafag. Okay, I'm gonna butcher it. Portfolio. Bank simulation. Someone's programming it a lot in C. DB design. Ooh, research grant management system. Ooh, fancy. Creating and managing a database for a council that oversees research grant applications, competitions, and review assignments. Ooh. Script creates and initializes an SQL database with the following tables: researchers, competitions, applications, collaborations. We actually have an SQLite manager installed. We could take a look. Where the hell is it? Council Pi. Oh, it's a script. Okay. Do. You just have an standalone SQL file, maybe? Probably not. Oh, this is kind of interesting. So like you have to use Python to create a database, right? Yeah. That's pretty cool. Okay, so what do we have here? We have researchers, bunch of researchers. Create table statements. Researchers, researcher ID, first name, last name, email, organization. Primary keys. References, researchers. References, researchers. You know? Some join tables. So I'm seeing many to many, one to many. Created, inserted, and wrote some query about it. Yeah. Execute create tables, reviewers, primary key, researchers ID, more joint tables. More joint tables. More joint tables. Assignments with conflicts. What is conflicts? Okay, so then you put these. Have a list. Try insert into researchers. Values, question mark, question mark, question mark. I'm not familiar with this. For table and tables, execute. Select from all table. Sprints things. Gotta go. Got a meeting in 5, then do some actual work till 16. Have fun and chill. Don't forget to chill. We will not. Thank you, Joker. See you around, man. Good luck at work. Okay, then it's fetching all. Okay, that's pretty cool. I don't entirely get everything. Probably would have to look at it for longer, but that's a pretty cool project. How much consider value with Python? Oh, okay. It looks pretty cool. It's been a while since I played around with Python. I miss Python, man. Even though JavaScript was pretty fun and SQL is quite fun too, I miss Python. The simplicity. Search SQL injection attack on Google. Yeah, I know. I know. I know injection attacks. What am I trying to do here? Right, I was trying to look how to reorder the thing. Intermediate indexes. Was it with index? Clustered indexes? Yeah, I think so. Create index cluster using this index. Yeah. Create index on the clustering was here, I think. No. Combining index only scans, non-clustered index, clustered index. There we go. Cluster customers. Oh, just use the index. Okay. Did we have an index even for customers ID? Yes, because we have a primary key for it. Okay, so cluster customers using? Yeah. Using customers P key. Oh wait, no, we need an index for it. No, it does already has an index. Wait, or does it? Oh yes, it's customers unique index using binary tree customer ID. Okay. All right. So do you feel ready for your exam, Orphan? Which year are you into, by the way? Oh no, we broke. No, we didn't break it. Okay, it worked. It worked! So, regular searches are done on the combination of customer ID and book ID on the orders table. You have determined through testing that this would be a good candidate to build a multi-column index on. Let's build this index. Okay. So, been studying throughout the semester. I just need to review. Okay, that's good. So, is this is it just SQL, or there's probably more stuff, right? Like Python and all the other stuff. By the way, is it comp science that you're learning, or something like more specific, or something entirely different? I'm like endlessly fascinated with people who are actually doing like university courses on programming, because I debated doing the same, but then I just chose to learn it by myself because I just have bad experience with universities. Like my finance bachelor was a living hell. But that could have been something to do with the fact that I was working at the same time, full time. So, you know. Hey, it's comp science. Okay. So what do you learn? Like, which year are you into? And what have you learned so far? If that's not too broad of a question. In database or in major? In the major. Uh, um, book ID does not exist. Oh, it's in books ID. Customer ID. Oh, crap. Hmm. So far I had courses about Python, C, CPP. What is CPP? Data structure and algorithms, assembly and CPU design, operating system. Okay. It's interesting because so far I have C++. Okay. Because I'm sort of in a roundabout way learning the same things. I did finish a data structures and algorithms course in Codecademy. I have learned Python in bootcamp. Um, assembly, not so much. CPU design and operating systems, yes, I have learned that from my, what was it? Comp something comp plus plus CompTIA, I think. Yeah, CompTIA course. What else? I have C in plans to learn that as well. So, okay. Interestingly enough, I'm not missing much. That's very cool. But probably the depth is the difference there. And the fact that you get to actually sort of test your knowledge in terms of like exams and whatnot and in projects. Whereas whereas in me, I just have to go like, well, I guess I've learned this and then move on. Though of course I could probably do sort of projects to solidify the knowledge too, which I've done quite a few. Hmm, that's interesting. I don't know, but I guess at the very least, at the end of the day, you get a diploma. I don't. In second year, there are a lot of these courses. What courses would those be? Like, what do you define as a shit course? Mm-mm-mm-mm. Like assembly? I mean, it depends. It's good to know low level. Is it useless? I guess it depends what you do with that knowledge afterwards. Like, you might need it at some point, or at least the basic understanding of what it is. You probably won't remember everything about it for like your entire life, you know. But you never know. You might start a job where you will need some knowledge about assembly, and you will have that. It'll save you some time. I don't know. At least that's the way I choose to look at it. But maybe if you know exactly what you're going to do after finishing studying, and you know that it's going to be useless for you, then yeah. Orders on, oh, not customers, orders. Customer ID, book ID. Yeah. You notice that your queries using your index you just built are also regularly asking for the quantity ordered as well. Drop your previous index and recreate it to improve it for this new information. Couldn't you tell me that before? Orders quantity? Yeah, we have it here. Let's take a look at our current indexes. Customer ID, book ID. I should probably rename it as well. ID quantity. Ah, crap. Cannot create regular file. Oh no! We broke it again. Damn it. Well, I guess we won't finish this today. Operating system is basic, but it really helps you understand how computers work, but assembly not. Okay. Well, I guess. Well, assembly, as far as I know of what assembly is, it helps you understand how programming languages work. No? I don't know much about assembly. Is any low language programming language with a very strong correspondence between the instructions in the language and the architecture's machine code instructions? Kind of, yeah. Can be used directly to tell a computer what to do. Is almost exactly like the machine code that a computer can understand, except that it uses words in place of numbers. Well, you never know. The world might end one day. We might have to rebuild everything from scratch. We won't have Python then. We won't have C plus then. All we'll have is zeros and ones. You will be invaluable then. You'll be the king of the new world, my friend. Okay, so we broke Codecademy again. I'm fairly certain. Yes. Okay. Third time. Let's move on to the database normalization. Like automatic and manual gear cars. Manual's outdated, right? No, it's not. by any means. I don't think so anyway. Then again, I depend. You don't agree? I mean, it depends where you live, right? Go to Russia. Try to find some manual cars there. I mean, automatic cars there. Go to go to Africa. Go to some any third world country. Go to India. It might be outdated where you live, but and here's the thing, like I'm not a car guy or a car mechanics guy, but like manual is a bit more reliable. Automatics they break more often as far as I know or something. So, there's always going to be a need for people that know the basic stuff. Because as we abstract up and up and up and up, there's going to be less people who know the basic levels. And when something breaks, you need the basic levels guy. Speak in general, could not find a better example. I mean, yes, there's a point for that. You're not entirely wrong, but I don't think you're entirely right either. Because the guys who know the basic stuff, they get paid the big bucks for a reason. Like in my previous job, right? I understand. Like for example, I was working in a cigarette factory, right? I understand how the machines work, right? How you get a tobacco, you combine it with the papers and apply glue and blah blah blah, put it in the packet, apply plastic on top of it, everything. I get the surface level stuff. I could even go into like adjusting the machine here and there, messing with the parameters a little bit. But then you had moments where something would truly break, something that no one's touched in like 10 years. For example, one of these there was like this sort of complicated gear system in one of the machines, right? And then no one's touched it for I don't know 20 years or something, and it broke. Nobody knew what to do. So they called this guy in Germany out of retirement because he's the only one in Europe who knows how to fix that stuff, fix it, and also set it up properly so it works again. So they called him out of retirement, and they paid him like 40,000 euros for like a week of work, just so he'd be able to fix that and get it going again. So being highly specified and knowing the basic stuff, that's where the big money is. At least that's my example. I might be talking out of my ass, so don't don't like grab your pitchfork. Okay, database normalization at Fred's Furniture. A new online furniture store named Fred's Furniture has hired you as their very first data engineer. Whoop-de-doo. Fred, the owner, knew when he started his business that he should be collecting data about orders, customers, and items. Unfortunately, Fred doesn't have a background in database engineering, so he's been storing all of this information in a single database table. Now that his business is getting a little bigger, he's finding it harder and harder to maintain his database, so he's hired you to help him redesign it. Over the course of this project, you will normalize Fred's database by creating a new set of tables that contain all of the same information. You then have a chance to explore how data modifications and queries befit or differ before and after normalization. Sure. Provided database includes order, customer, and items data for Fred's first month of business, which is contained in a table named store. Holy crap. Fred's database, which contains a single table named store, has been loaded for you. Write a query to select first 10 rows, all columns from the store table, and inspect the results. Okay. What do we got here? Lots of stuff. Order date, customer ID, customer phone. Okay, we have order stuff, we have customer stuff, and we have item stuff. Item 1 ID. Item 2 ID. Item 3 ID. All right, join these into one table. Split it off into its own separate thing. Do the same with don't need to combine any of this. Just split this off into its own thing. And just leave the orders table. Oh, we're fine. Wait, what happened with my thing? Everything broke this morning. Jesus Christ. Thank you for the follow, Orphan. Even my freaking alert box broke. What in the hell? Okay, I'll have to fix that this evening. All right. Okay, so have any customers made more than one order? Distinct. Oh. Ah. Order ID from store. Good luck. Let me know if you need any lecture notes or something like that. I mean, if you have them, I wouldn't say no. Like, depends on how you have them. Like, if you could share everything with me, that would be nice. If you have them in like something like OneNotes or something, I'd cruise through it. Would be very useful. Other than that, probably like more specifically, I don't know, C. Anything on C that you can give me? Because we'll probably tackle that either next or in a couple of weeks. By the way, since you're new here, we stream every day, basically. And on weekends, we do gaming. So if you're into that, you can check that out too. So, 100 distinct orders. Ah. Let's inspect some of the repeated data in this table. Write a query to return the customer ID, customer email, and customer phone where customer ID equals 1. Okay. 2. It's 4:06 in the morning. What are you doing awake? Give me a Discord or something. It's in the channel description. Go to sleep, dude. Don't worry about it. Go to sleep, wake up, and then you can find my channel again and go to Discord and send me stuff. Don't worry about it for now. Off to bed with you. 4 o'clock in the morning. Jesus Christ. Okay, that's done. There's probably even more repeated data in the item-related columns. Write a query to return the item ID 1, item name 1, blah, 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 where item 1 ID equals 4. Okay. Item 1 ID. Item 1 name. Item 1 price. Where item ID equals 4. Lamp, lamp, lamp. Lamp, lamp, lamp. Okay. So below it is a database schema for a normalized version of this database. All right, talk to you later on Discord. Have a good day. You too, man. Have a good sleep. See you around. Thanks for stopping by and chatting me up. Have some good dreams. Use create table customers as to create the customers table described in the schema by querying the original store table for the relevant columns. Make sure the only include one row per distinct customer ID. We need to take a look at how that's done. I forget. Where was it though? It was in normalization. Here, I think. Back. Back, you demons. Table advisor. Holy crap, this song brings back memories. Not good ones either. Restructuring the advisor column. No, no. Where the hell was it? It was somewhere with normalization. But was it here though? Hmm. Ah. Or was it here? No, that's just the quiz. It's email structure, blah blah blah. There was somewhere an example of how to create a new table with data from another table. There. Create table as. Yeah. Okay, so create table as create table customers as oh, and then we do a select distinct, right? Select distinct. This is going to take the rows, though. Make sure to only include one row per distinct customer ID. Okay, so customer ID. From store. Customers. But we also need the phone numbers and the emails. For relevant columns. What if I do customer phone, customer email? Okay, so this created a separate table, but do they match is the question. Store. Okay, so it's not been normalized. Where customer ID is equal to 1. No, not 1. 45. So the phone number matches and the email matches. Okay. Yeah. It works. Use the following syntax. Designate customer ID column as a primary key for your new table. Sure thing. Alter table customers. Add primary key customer ID. Customer. Please, customer. Buy some things from me. I am but a poor merchant, living off of my lowly wares. And you, the grand customer, providing sustenance for me and my family. Please. You'll also need to use alter table here because the customer's table was created by querying an existing table. Therefore, it was not possible to set primary key constraint within the create table statement itself. You'll also need to write this code after the create table statement from the previous step because tables are deleted and recreated according to script SQL every time you press save. Yes, I'm aware of that. Thus has been done. Use create table as to create items described in normalized schema by querying the original store table for the relevant columns. Make sure to only include one row per distinct item ID. Sure, that's basically just doing the same thing. Create table, items, as, select. Hey, long live Chaos9, Twitch scam. Twitch scam. Thank you for the follow. Are you a Twitch scam? Haven't you followed like before? Yeah, like 7 days ago. Mr. Twitch scam. Select table, select distinct. The hell do we have? Item 1 name, item 1 price. Huh. So is it selling just 3 items? I think so. The poor merchant is only selling 3 wares. Look at him. Leave this wretched place and come to my store where we sell thousands of items. Jeff Bezos, probably. Okay, so do we do just all the items? Makes no sense. I'd rather have create tables select as distinct. Item, item. We need item ID, item name, and item price. Huh. Can we do like, okay. Item 1. Name as item name. Then item 2 name as item name. And item 3 name as item name. And then do the same thing for price. We also need IDs too. ID. ID. Okay, chaos, last warning. Either be human or we're gonna have problems. Item name. Well, let's try with our current approach. See what happens. Item 1. ID as item ID. And just copy this, 2 more times. Item 2. Item 2. No, 3. And price. Item 1. Price as item price. One, two, three. Okay. Item 1 price, item 2 price, and item 3 price. I'm not confident this will work. Or what the hell are we going to create with this? But we can take a look. From store. And then immediately, let's select all from items, limit to 10. Oh. Ah. Oh, can I do... Wait. Huh. Item 3 ID as item ID. And what if we put these in parentheses? Separate them with commas. Will this work? Maybe. Item 2. No, 1, 2, 3. Except ID we do price. Weird. I thought someone was calling. Someone calling? No, I don't know. Price. No, name. And name as item name. And then price. Works? No works. Relation items does not exist. Huh? Why not? Syntax error near from. Now? No. Column item ID has pseudo type record. Huh. Oh, union them. Okay. Bum, 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 bum. Item 1 ID as item ID. Item 1 name as item name and item 1 price as item price from store union, and then we do the same thing 2 more times. Item 1 name as, wait, crap. Item 1 ID, item 1 ID, item 1 ID, item ID. Shit, wait. Crap. Okay. ID name price. ID name price. I just need to change the numbers. Yes. This gets confusing. 3, 3, 3. Matter of fact, we also need to add a from statement or where statement where item 2 ID is not null. Item 3 ID is not null. Think that's about it. ID name price, blah, 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 blah. Let's see. New. Item 33 price does not exist. Where did I write? Oh, makes sense. There we go. And we have, we have more than 3 items. The hell? Okay. Well, it seems this merchant has more than 3 items. Well, let us peruse the store and take a look-see. Why don't we? All right, so we got our second table. And now we just need... in matter of fact, he has 50 items. It's still no match for my 1,000 items store. Jeff Bezos, probably. Okay. So now, alter table. Items, add primary key, item ID. Yep. Atler. Alter, please. Use create blah 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 to create orders items table described in normalized schema diagram by querying the original store table for the relevant columns. First few rows of order items should look something like this. Okay. Orders items as select. So we need distinct item names and order IDs and item IDs. Right? And we also need to spell it correctly. Distinct item crap. We now need to do the union thing again, I think. with the price thing, right? Yes. Order ID. Select order ID. Oh, yeah. Okay. Select distinct order ID item 1. ID as item ID from store. Item 2 ID as item ID from store. Where what? Where order ID is not, or should that be item 2 ID is not? No. Yeah. Item 2 ID is not null. And we also do let's do the same thing with item 3. And now if we take a look-see, nope, near select distinct, relation orders, just select. Is it select distinct? No, just select. Okay. Line 8. Order ID. Item 1 ID. Item 3 ID. Oh, we forgot the union. Okay. So discrete relations. Use create table orders as to create orders table described in the normalized. Oh, crap. Oh, this is orders items. Okay, we didn't do orders yet. Matter of fact, let's take a break. It's been a while. 10 minutes as usual. Oh my god, why do I have to click? Oh. Yeah, I know, Thor. I'm excited for the day to end as well. He's like, play with me. Come on, play with me. What are you doing? Just sitting at your computer for 8 hours a day. Play with me, you little wind person. All right, let's go back. Finish this project one of these days. So, orders. Orders need order date and customer ID. And order ID too. Okay, create table as orders. Select order ID. Order ID, order ID. Order date and customer ID. You weirdo, stop eating in your bed. Jesus. From store. Eh? I swear to God, he's the weirdest dog ever. He grabs a mouthful of food, brings it to his bed, eats it here, then walks back to his bowl. Oh. All night long. Designate the order ID column of the orders table as the primary key. Orders. Order ID. Dunzo. Copy and paste following code to designate the customer ID column. Blah, 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 blah. Sure. Come on, copy. You weirdo. Designate order ID column of the orders items table as a foreign key referencing order ID column of the orders table. Alter table. Not tail. Table. Designate order ID column of the orders items. Orders items. Add foreign key on order ID. Referencing the wait a sec. Oh, okay. No. Do this and orders items. Order ID. References. Referencing the order ID column of the order table. Orders. Order ID. We have an order ID in orders. Yes, we do. I think that's how you do it. Okay, congratulations, you now have sets of database tables that contain the same information. The first has a single database table named store, the second has 4 database tables. Due to the constraints of the learning environment of Codecademy, all of these tables are currently stored in the same database. However, for the remainder of this project, we're going to imagine them as separate databases, one that's not normalized and one that is normalized, so we can compare them. Okay. Query the original store table to return the emails of all customers who made an order after July. Okay, so select store, customer email from store where order date is greater than 2019 0725. Bam. Okay. Now query your normalized database tables to return the emails of all customers who made an order after July. Normalized data orders, item, customers, items. Is this easier or more difficult to do with the normalized data tables? Where are our emails? In the customers table. So select customer email from customers where now we have to join them. From customers orders where customers dot customer ID is equal orders dot customer ID, right? And order date is greater than 2019 0725. Gave us the same thing. Marcus, first thing. Ramses, the second. Wait a sec. Order by customer email. Okay, Asia. All right, we got the same data, I think. Right? Oh, shit. Oh well, whatever. Let's just say it works. Query your normalized database tables to return the number of orders containing each unique item. Each unique item. Actually, let's hide this. Oh, so behind this. Normalized data table is to return the number of orders containing each unique item. Okay. So we need orders and items. So from orders and items. Where orders dot order ID is equal need orders items. Orders items. Oh my god, what are these messages? I've been awake for 26 hours only. Casually. Hi, great streamer. My friend is one of the big streamers of Twitch. Pointed out something on your channel that prevents you from having more engagement. Right, sure. Problem, greater detail. No, thank you, Jack Smee. I'm okay with my Twitch stream. But I appreciate your friend's input. I don't know why he cares. I don't know why you do either, but thank you. Hobby Minion, welcome to the stream. Bum, 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 bum. How? Why? Okay, explain to me, why have you been awake for 26 hours? I'm genuinely interested. Is there a story behind it? It's a bit. It's a bot. Yeah, I know it's a bot, but I do get these like propositions fairly frequently, and sometimes it's not a bot. So at least I want to give it some chance, you know, to treat it as a human being. Yeah, Bobby, I know you're real. 15-hour-old pups. Holy crap, what kind of pups? Tell me everything. I love dogs. And 7 of them. That must be exciting. So, though I'm not entirely sure why do you need to be awake for this long? Do you have to like constantly keep an eye on them? Well, of course you do if you're awake this long, but like why? Oh, Frenchies. Oh, that's cool. I like Frenchies. What do I know about Frenchies? They're small. Of course they're small. They're kind of independent, I guess. Uh, and the mother looks like she saw stuff. Anesthetict. Huh? Oh. Wait, so you have to anesthetize the mother for the birth? I can't spell. That's fine. You've been awake for 26 hours. Some allowance is a given. Okay. So just in case she bites the pups. Okay. Yeah, the pups at 10 p.m. and it's 1 p.m. Dude, I do not envy you. I know what I very intimately know what it's like to stay awake for very prolonged periods of time, and I would not wish that on my worst enemy anymore. Just based on the amount how like at least it's a one-off thing, you know, or maybe two-off thing at best. Stuff makes them act kind of drunk. Well, yeah, anesthetics tend to do that. When will you be able to go to sleep? Can't sleep till at least 6 or 7 p.m. So 5 more hours. Damn. No one else can keep an eye on them? Probably not, since you've been awake so long. Yeah. Well, I mean, just a few more hours. Better make some coffee. Everyone was asleep. I'm not even tired. Well, at least you got that going for you. Just my eyes battling to shut. So you are tired. Well, congratulations on your puppies. Don't like coffee or tea? Uh, energy drinks, or you know, there's some some less legal options. You don't also feel tired ever? Must be amazing. How come? Are you just really on top of your sleeping schedule? Sleepy music's probably not helping. Try something else. Yeah, there we go. Okay, we're done with this. Wait, we're not just yet? Ah. There we go. Academic normalization. Oh crap. Academic stuff. Boring. So have you got the names for the pups yet? Also, what are you gonna do with them? Give them away, sell them, keep them maybe? If you're taking a college course about databases, you will likely run into formal terms about normalization. In this article, you will learn what 1F, 1NF, 2NF, 3NF normal forms and how they relate to update, insertion, and deletion. What is an F? In most academic situations, the term 1NF, 2NF, 3NF will be the formal vocabulary for describing normalized databases. But what do these terms mean? In each term, the NF stands for normal form. The numbers stand for what level of normalization the database is. A 1NF database. The first type of database we'll talk about is the 1NF database or one normal form database. A 1NF database is an atomic database. It's when each cell contains one value and each row is unique. We use the term atomic to indicate that the data is no longer divisible, like an atom. For example, of a non-1NF database can be seen below. Okay, so book title, book author, address, sales. Roger that. We can look at this database and see that we have two different values in the book title column for the... Okay, this causes problems for us if we wanted to get information specific for Lord of the Rings, as we would get information for The Hobbit as well. Ah, I see. To fix this issue, we would separate the two books into their own rows. Yes. Now when we want to get information on Lord of the Rings, we can get the information specific for that book. However, there are still some issues that can happen with this database that we will discuss soon. What rule needs to be followed for a database to be considered is atomic. 2NF. When normalizing a database would be to make the database 2NF. It means that the database is 1NF and does not contain any partial dependencies. But what is partial dependency? A partial dependency is when an attribute depends on part of the table's primary key. When an attribute depends on part of the table's primary key rather than the whole primary key. Okay, so primary key. With this table, we can see that there is an ID for the book and an ID for an author. We can determine that the book title based on the book ID and the author based on the author ID. These are both partial dependencies, since the author ID depends partially on the book ID. Ah, I see. Now, when we want to look at the database, we see that the author depends on the author ID in its own table rather than the author depending on the author ID, which then depends partially on the book ID. That means if we want to find the author, we can just use their ID rather than finding the book ID and then the author ID. This also helps prevent a few anomalies when updating and deleting data from the database. For instance, if we wanted to update the address of J.R.R. Tolkien, instead of finding every one of his books in the book.db table and updating his address, we can update his address from the author.db table once. This decreases the chances that we miss updating one of the author address records, which would lead to J.R.R. Tolkien having two separate addresses in the database rather than one. This would be called an update anomaly. All right. This also keeps us from deleting an author from the database unless we want to, otherwise known as causing a deletion or anomaly. So, no partial... Wait, what? 1F10 that contains no partial dependencies. Okay, what type of anomaly would lead to a different record lead to different records existing for the same object? Insertion anomaly? No. Update anomaly. Yes. 3NF database. The last level of normalization we'll cover in this article is to make the database a 3NF. A database is described 3NF when it is 2NF but also has no transitive functional dependencies. A transitive functional dependency, or a TFD, is when a non-prime attribute depends on another non-prime attribute rather than a primary key or prime attribute. Okay, so let's go back to our book database to see an example of this. Let's say we wanted to find the author's address. We would first go from the book table to the author table, and then from the author table we can find their address. This might not seem like a big deal, but the address is dependent on the author. Meaning, if we were to delete the author, we would come across another deletion anomaly. To fix this, we would create a table for the addresses. Ah, I see. Okay. Now, when we want to find the author's address, we start with the book, find the author, find the address key in the author's table, and get the address from the address table. While this may seem to increase the number of searches done in a query by connecting more tables, it saves us more trouble down the line by not having to add multiple addresses if multiple authors are in one building, or by having to add an address again if the author is deleted from the database. Another modification we can make to our database is to make the book sales a table of its own. This would be useful if we add books before they're published, as it would prevent insertion anomalies from happening. And that is when a row is added to a database without all the data it needs. For instance, if we wanted to add a book to the database before it sold a copy, book sales would be null, causing an incomplete row, which could prevent us from adding a book to the database. All right. So, when the database is 2NF and contains no transitive functional dependencies, or TFDs, what anomaly occurs when null value is preventing us from adding a record to the database? Insertion anomaly. Okay. So, we are done with normalization. Except for this thing. Can we just do, like, pretend that we did it? Because this is crazy. So, advanced PostgreSQL, database maintenance. We still have to look at that. But beside that, that should be it. Okay. Postgres SQL database maintenance. Holy crap, there's quite a lot. Vacuum full, analyze and auto vacuum, introduction to vacuum. Ugh. Okay, let's try and finish this today. When you download a CSV file from the internet, you might designate a download location and then write a program to pull data from that location for analysis. Did you just turn off shuffle just for Eminem? Yeah. Okay. Okay. In the middle of the playlist, as it was playing, after the entire week of me struggling with YouTube Shuffle, it decided now to turn off Shuffle by itself when Eminem's song started playing. Okay, YouTube, you do you. Although there are significant differences between accessing data from a CSV and a PostgreSQL database, the data you're accessing is still stored on a disk. Because PostgreSQL stores data on a disk, you should take care to manage that storage like any other set of files. Just as you might only want to keep the most recent version of a large CSV file on your computer, you'll want to keep your PostgreSQL database consuming only the disk space it needs. The space PostgreSQL uses on your disk can grow in several ways. Some ways are easier to predict, for example, the addition of new tables or the addition of more data to the table. However, there are some properties of the PostgreSQL data storage system that can cause disk usage to increase in non-intuitive ways. For example, table sizes can increase after update statements, or a delete statement that removes millions of rows can result in no change in total database size. Ah, okay. In this lesson, we'll discuss some of the ways that you can manage the size of your database tables. Keeping the tables and indexes in your database small can ensure better quality, better query performance, more efficient disk utilization, and lower database costs. So, currently the database has a single table named mock.timeSeries, which is a series of 100,000 random values. Select the first 10 rows of time series and become familiar with the data. Select all from time series and limit that to 10. Timey-wimey something something Doctor Who. Eh. Excuse me? Oh, mock. Okay. Okay. Next. Understanding object size. In order to manage database disk utilization, you should first be able to measure disk utilization. As a database user, you can use the following functions to check the size of a relation in the database. So, total relation size, PG table size, or PG size pretty will return the size of the table and all its indexes in bytes. These values are often in the millions or billions and thus are hard to read. Will return and tables indexes in bytes. The sum of these two functions is equal to PG total relation size. Okay. And PG size pretty can be used with the functions above to format a number in bytes as kilobytes, megabytes, or gigabytes. All right, so all of the logic to get the table or index size is in the function itself, although PostgreSQL does store table size in specific internal tables. You can simply write a statement like select PG blah 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 blah, get the table size. So from this query, we can see that the table has an index with the size of about 180 kilobytes, data size of about 350 kilobytes, and total size equal to the sum. Because indexes are relations in their own right, you can also call PG total return relation size on a single index to get the size of the index. PG size pretty okay. All of this terminology. Jesus Christ. I don't think I'll need it. When you select a function value, the column in the response will have the same name as the function. For clarity, it can help to include as desired name in your queries. Otherwise, columns in the response would be named PG size pretty. Okay, so there's a table in the database named house prices, which contains several thousand fake house prices and locations. Write a query to find the total size of the table data in mock house prices. Throughout this lesson, your answer should be wrapped in PG size pretty to make the results more readable. By default, it names the column in your response, but for these exercises, you don't need to worry about aliasing the size columns to a different name. All right, so we do select PG size pretty, and we do PG total relation size of mock dot house prices. That it? Well, total table size. Is that not the total table size? What the hell? What's your problem, Codecademy? Oh, it's just not happy that I don't have a semicolon. I did have a semicolon. What's your problem? PG size, pretty. Okay, just do the thing. Okay. Updates and table size. Each row in PostgreSQL table is stored in a file on a disk of the host machine. When an update or delete is called, Postgres doesn't physically delete the content from the disk. Instead, the database engine marks those rows so that they aren't returned in user queries. Those rows are called dead tuples, and although they aren't referenced in the current version of database tables, they still occupy space on disk and can affect performance. So imagine table sensor data that receives values from dozens of temperature sensors every second. Occasionally, the sensor will write multiple entries per second, adding an extra row. When this happens, the old entry for that second will be marked invalid. Okay. Over time, querying this table for valid rows will become more expensive because PostgreSQL will spend more time scanning over potentially millions of irrelevant rows. Keeping millions of unneeded rows could have a significant impact on query performance. This example is a simplified version of what PostgreSQL does behind the scenes when you update a table. It creates a new row and marks an old row invalid, causing the size of the table to increase. Okay. So update to test how the table size fluctuates. Because the column score was randomly generated between 0 and 1, the following should affect about 10% of the rows. Okay. The query updated 9.97 values but didn't add any new data to the table. So why is the table larger? The table grew about 456 kilobytes because of the way it updates internally. The additional 400 kilobytes or so are the dead tuples created from this update. Okay. So we just try to update shit. Now, is the same as previous. Exercise contained 5,000 observations of mocked house prices. Check the total size of the table. PG. PG. Size. Pretty. PG. Total. Relational size. Yeah. Total relation size. Mock dot house prices. All right. So someone's made a mistake in the data and must update the broker ID for all houses. For all houses listed with broker ID GE to GA. Okay, so update mock.house prices set broker ID to GA where rerun the query. Boom. Increased size. Introduction to vacuum. In the last exercise, we discussed ways to monitor disk usage. There are also statements you can use that allow you to actively manage disk usage. In PostgreSQL, there's an operation called vacuum that can be used to manage storage space. Running vacuum table will vacuum a specific table, while a vacuum statement without a table name will run on the entire database. If you only check the total relation size, you may not see much of a decrease in space before and after vacuum. This is because a plain vacuum will only clear tables dead tuples where possible. Depending on which rows in your table are updated, this can clear anywhere between 0 and 100% of dead tuples. Okay. So if vacuum cannot clear the dead tuples, gotta get work done, so I'll only be here for a few. No problem, Remy. Welcome to the programming part. I don't remember if you were here for any of the programming streams or just the gaming. Wait, let's see. You followed 3 days ago. So yeah, you were only for gaming streams. So this is what we do for most of the week. How's your Monday been so far? Cannot clear the dead tuples. PostgreSQL will mark the space occupied by dead tuples for reuse when new data is inserted into the table. We'll discuss parameters that can be passed along with the vacuum that promise to return more space to the disk. Recall from our previous example using time series that when we update our table with about 10,000 new values, we also created about 400 kilobytes of dead tuples. Okay, so blah 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 blah. Where do you use vacuum? Oh, here. After updating the tables, you can see an increase in disk space used by this table. Now let's consider how vacuum can help us minimize the effect of new updates. Vacuumed. So it did nothing. Unfortunately, we see that no space has been returned to the disk. This is a bit disappointing, but what the vacuum has done is allow this space to be overwritten by subsequent operations on that table. Let's see what happens when we perform another update similar to the previous one. It increases less space. See that the table has grown by only an additional 8 kilobytes instead of 400 kilobytes that the first update produced. In this case, the space that we marked safe for overwriting with vacuum was used, so the table didn't have much more space on disk. Okay, database has a table which contains the prices for fictional company. We just check the table's size and have following statistics. Due to an error, the prices, column price SH, after January have been reported as $10 lower than the correct price. Add $10 to all the values after January. Correct this mistake. What is January? 0101. Right, of course. Okay, so select. No, not select. Update. Stock. I can't type anymore. Jesus Christ. Stock prices. Set. Price. SH as price. SH plus 10. Where date? Trading date. Trading date is greater than 1/1/2020. Okay, so now we vacuum. Mock stock prices. I did the thing as total size, right? Come on. Date. Uh. Previous lessons we discussed the vacuum command and its limitations. One nice property about vacuum is that it allows space to be reused. If tables are vacuumed frequently enough, the disk usage of the table will stay relatively steady because updates will never get too far ahead of the required space on the disk. To ensure that vacuuming isn't left completely to the database users, PostgreSQL has a feature called Auto Vacuum enabled on most databases by default. When using Auto Vacuum, PostgreSQL periodically checks for tables that have had a large number of inserted, updated, or deleted tuples that could be vacuumed to improve performance. When Auto Vacuum is enabled and finds such a table, a vacuum analyze command is run. The statement is a combination of two separate operations, vacuum and analyze. You can leave running vacuum and analyze statements to the auto vacuum process if you like. However, you can also run it yourself or just analyze table if you haven't made large inserts or updates and would like to update blah 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 blah. You can monitor the last vacuum or auto vacuum by querying the table pgstat all tables for vacuum and analyze statistics. Holy crap. Okay, I'm kind of falling asleep here. Jesus Christ. Okay, let's leave this for tomorrow. It's about time to end the stream. We're still on databases. Holy crap. This was supposed to end ages ago. This was three hours worth of stuff. And it's been going on for a week. Crazy. Crazy. See if our stream ending soon thing is... Nope. Broken. Oop. There we go. I'll have to do some cleaning up after today's shenanigans. Or maybe not. It's fine. And I'm alright. Yeah, yeah, yeah. What a weird Monday. Dude, like, I'm both tired and feeling like I didn't do too much today because of the whole shenanigan with the DB manager from the company. It's a bit crazy. Hey, Tiburian. You're like, okay, bye. Have you been here the whole time? Or did you just come here just now? I'll still hang around for like 20 minutes if you want to chat. Not really work. I see. Okay. Well, if I don't stay on my account, you gotta do work, go do work. I'll catch you tomorrow probably. For a long, long time. But yeah, thank you all to all the people who came out today. Especially those who chatted. We have Happy. We have Irfan. Joker stopped by for a bit. Bobby Minion and his new puppies. Remy, and also Tiburian. Thank you guys for stopping by so regularly and just having a chat with me. Great, it helps greatly. Allows me to take little chatty breaks and not go insane with SQL. And also everyone else who watched, who just lurked around and did their own thing. That's also fine. Much to say. Also, I do have a Discord. I will post some updates if something comes up there, and you can also catch me there after your works or something if you want to chat about something, or just maybe play games after my stream. Really, I'm down for anything as long as if I have time. Other than that, what else? Oh yeah, I also uploaded last week's streams to YouTube, so they should be live on my YouTube channel now. If that's something that you're interested, want to catch up, see what we were up to last week, or if you want to see the gaming streams from the weekend, that's also a thing. This week we played a poker roguelite called Balatro, and we also played backpack battles. Yeah, basically you build your own backpack, and then the backpack fights against another player's backpack. I don't know. It's weird. But it's fun. It's a lot of fun. Anyway, what else? That's about it. So I guess that's the end for today. Thank you, everyone, for stopping by once again. And I will see you tomorrow. Hopefully, in a more streamlined and familiar stream than it was today. Anyway.